Yes, good day everyone. Today the topic before us is indices and its laws. Indices and its laws. Indices is one of the ways of writing large and small number in simple form to save time and space. If you're a science student or a technical student, you need this. You need to know what indices is all about. You need to know standard form. You need to know how to interpret. You need to know prefix and suffix that involve writing bigger values of numbers in a very small simple form. So ọ̀pọ̀lọpọ̀ ìgbà míì máa ń wà tá a máa nílò láti kọ àwọn nọ́mbà àwọn figures tó máa pọ̀ like 10 of thousands, thousands of millions and all of that. Yet tó yẹ pé a nílò láti kọ ní péréte tí ò ní gùn tí ò ní pọ̀ rárá. Tá a bá sì kọ ní péréte tí ó sì yé wa. That some of the surveys I'm talking about is let's say 1000, which is also 10 to the power what 3, which you can say 10k. This k means what? This 1k. Do you get it now? Which it means what? 1 kilo. Kilo means 1000. Do you get it now? So you need all those suffix, all those simple ways in writing bigger values. Usually if you are in physics, if you're a science student, you are in physics class, then sometimes you need to get to know this. So example of all this, in the 10 now. 10 simply means, in a very simple way, means what? 10 raised to power 1. Because that power is saying that 10 you èmejì ẹ̀kan la nílò rẹ̀. That is 10. So tó bá yọ pé ẹ̀kan náà, that means 10 times 1 or 10 lẹ́ẹ̀kan, that is still 10. See, check 1000. 1000 òdo mélòó ló ní? Òdo mẹ́ta. Ẹ̀mélòó la nílò 1000. Ẹ̀mélòó la nílò 10 fún 1000. Ẹ̀mẹ́ta. That means if you can have 10 times 10 times 10. That means this is 10, this is 10, this is 10. So 10 lọ́nà mélòó? 10 lọ́nà mẹ́ta. They give you what? 1000. And a small number, our number kan náà dẹ̀ wà tẹ́lẹ̀, they are less than what? Less than 1. Our number to less than 1 is 0.1, 0.5. They are not up to 1. And most of those numbers are what? Decimal numbers. They are less than 1. Do you get that now? They are less than 1. So for example, this is 0.1 now. It's 10 to the power minus what? Minus 1. 10 to the power minus 1. Which it means that we are saying that 1 over 10. Do you get now? This minus 1 over 1 is what? 1 over with this 10. Do you get that now? So that's how you write it. And by the time you use your calculator to say 1 divided by 10, a fẹ́ pín 1 yìí a fẹ́ pín sọ́nà mẹ́wàá. Tá bá pín 1 sọ́nà mẹ́wàá, mélòó ló fún wa? That means ọ̀nà kọ̀ọ̀kan ó jẹ́ kí ni o 0.1, 0.1 lọ́nà mẹ́wàá. Do you get that now? So that is what? 1 over 10, which is equal to 10 to the power minus 1. Now see this one, 0.001 also is what? 10 to the power minus 3. Do you get that now? 10 to the power minus 3. That means we are dividing 1 by what? 3 times. So we are dividing 1 by 1000. Do you get it now? So all these are what? They are in standard form for positive and small numbers. Don't forget, the positive small numbers less than 1, they are what? Any number that is less than the 0.9, 0.5, 0.2, 0.1, they are what? 0.001, they are what? Numbers that are less than 1, they are lesser. So and all this you are seeing, this 10 to the power 1, 10 to the power 3, 10 to the power, they are what? They are in standard form. They are in standard form. These are the normal integers, normal numbers. Do you get now? But in standard form. A number written as x raised to the power n is in index notation. Is in what? index notation. Index notation, and it is called what? Indicial number. So when you see this x to the power n is what it is, in what it is called indicial number. This indicial number. So the indicial form of 1000 is this. So kì í ṣe nǹkan tó le rárá. Àwọn foundation ọ̀pọ̀lọpọ̀ àwọn nǹkan tí àwọn èèyàn máa ń rí that you have to solve along the line as you are going from GS1, GS2, GS3, SS1, SS2 till tertiary institution. Because you know that in this channel we're always talking about the foundation. Foundation is very important. That's why we are taking our time to explain some foundational or basics about this course of study. So a number written as x power is what you can see. This is x. This x here represent 10, and this n here represent what? 3. So it is called indicial number, where x is what? Is the base. When you see this one, that's the base, and where n is also what? Is called the index or the exponent. Index or exponent. That's why it's called indicial number, because it is talking about the exponential value of a number. Exponential equivalent value of a number. Okay. Tí n bá fẹ́ kọ 1000, tí n bá fẹ́ kọ ní Google báyìí, báwo mo ṣe lè kọ? Mo ṣe kí ni o? Mo lè kọ ní 10 to the power 3. Very simple. Let's say this is what? This is 10,000. I can write what? This will be what? 10 to the power what? 4. Let's say this is what? This is 100,000. It will be what? 10 to the power 5. That's as pushing low nìyẹn. The plural form of index is called indices. So you know we have singular and plural. So when you have single, something that is talking about just one. When you have plural, we are talking about many. So when you have value greater than what? Greater than 2 or greater than 1 rather, then you use plural, and the plural meaning of index is called indices. And the following are the basis law of indices. We have as many in indicial expression, but if you can know these 7, if you can master these 7 and understand it, those are the basis for other indices that you may encounter in other area in mathematics. So, and all these laws are valid if a is not equal to what? This a is not equal to 0. All these are valid if a is not equal to 0. All these basic laws of indices are valid only if you have your what? A, which is the base, which is not up to 0. So let's consider one. The first one, a raised power n times a raised power m is equal to what? A raised power n plus m. The second one is a raised power n divided by a raised power m, which is equal to a is equivalent or is equal to a is equal to n raised power minus m. A naught, a raised power 0 is equal to what? 1. I think that's nǹkan tó pọ̀lọpọ̀ mọ̀ nìyẹn. So tá bá mú value àti value tá bá mú papọ̀, another value. By the time tá bá solve law, you will understand better. This is open bracket an into close bracket m is equal to what? A open bracket am is equal to m is equal to a what? Power mn. It's just simply you multiplying m times this or n times this. That's it. So that's not like multiplication. So like what I told you earlier before in the number lesser than what? The number less than 1. So you have a raised power minus n is equal to a 1 over a raised power n. That's the value. N root a is equal to what? A minus n. So a raised power n over n is equal to m root a n raised power n. So equivalent and all of that. So let's consider some examples and solutions. So regarding first law, which says that what? A raised power m times a raised power n is equal to a raised power m plus n. Let's consider it. For example, a raised power 4 times a raised power 5. Ìtumọ̀ ẹ̀ ni pé a yìí o, a ní a ní ọ̀nà mélòó? Ọ̀nà mẹ́rin. Tá a bá ní a lọ́nà mẹ́rin, that means a times a times a times a ní ọ̀nà mẹ́rin. A raised power 5 ó mean a ní ọ̀nà mélòó? Márùn. A times a times a times a times a mélòó ní a ọkọ ọ̀nà márùn nìyẹn. Now àwa fẹ́ mú a lọ́nà mẹ́rin àti a lọ́nà márùn a fẹ́ multiply papọ̀. Do you get it now? Let's say we have this question now. So what do you have? A lọ́nà mẹ́rin òní multiply by a lọ́nà márùn òní. Now let's count how many a will you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a times 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 a, which is what? A to the power 9. So now instead of you now begin to express it, do you get it now? Begin to look for how to get this. Do you get it now? How to do this? Then instead of begin to make this out, then simply because you have that, you know the law. You know the law that okay, a is power m times a is power n equal to a is power n plus n. You can simply do that. You have a is power 4 times a is power n, and the base are the same. In English, the base must be the same before you can apply those laws. And don't forget that a, which is the base, must not equals to 0 before you can apply those laws. So a is having the same base with this a is power 5, so we have single a. So you take one of it. Let's say this is 10. You get it now? You have to take one of these. This must be 10. This must be 10. Their bases must be the same. So we have this. Then we have. So in this like this now, our m will now be equals to what? M will now be equals to 4. From this, m equals to 4. While n will be what? Equals to what? 5. Do you get that now? So n is equal to 5. So with that now, you say a raised to power 4, which is our m, plus a raised to power what? 5, but plus 5, which is our what? N. So if we add the two together, 4 plus 5 will give you 9. A is to power 9. You can see we have the same answer. You can see how easy and simplified it is. You just need to master this. So the second one, 5 is power 12 times 5 is power 7. You get it now? You must first of all consider the what? Consider the base. It must not be equal to 0, and consider that the base for the two values must be what? Must be the same, and you must consider the what? The multiplication value between them. Do you get that now? So you take one of this. Wàá wo méjèèjì. 5 is power 12. Ó mean pé 5 lọ́nà méjìlá. 5 is power 7. Ó mean pé 5 lọ́nà méje. Now that means, and the base, you take one of the base, then 12 plus 7, you have 5 raised to power 19. Do you get that now? So you see, the second law is talking about a raised to power n divided by a raised to power m, which is equal to a raised to power n minus m. How do we do that? I need a raised to power 5 divided by a raised to power 4. Ó mean pé kíni o? Mo sọ wípé ó mean pé a lọ́nà márùn, àbí? It means a in 5 places. So this is a in 5 places divided by a in 4 places, àbí? A in 4 places. Now divide by this. This one we call this. This one we call this one. This one we call this one. This one is this. This one. You are left with just single a. So with this single a, it will just what? Raised to power 1. So let's see if we use the formula instead of going through this stage. Let's now see a raised to power m. This at this stage, our n is what? N is equal to what? 5. While our what? While our m is equal to what? 4. Abi? So what do we need to do? Then we have a divided by this. A is power 5 divided by a is power 4. Base. Their base is the same. This is a. Then what is our n? Our n is 5. What is our minus? What is our m? Our m is 4. Based on this, then you have 4 a is power 5 minus 4. 5 minus 4 will give us 1. A is power 1 is equal to what? A. Do you get it now? So this is another example. 2 raised to power 3y divided by 2 raised to power y is equal to what? That means I need base 3y. I need base to get 2. Then this is 3y and y meta at y can. Then divided by this, then you have, what do you have? 2, 3 minus 1 minus 1. Taba your y can kúrò nínú y meta, kí ló fún wa? Ló fún wa ní y méjì, that is 2y. So that's that about that. So That's that. So the third law, we see that a naught is equal to 1. A raised to power 0 is equal to 1. So since a raised to power 3 minus divided by 3 is equal to what? Is equal to a raised to power 3. Ó mean pé a lọ́nà mélòó? Mẹ́ta. A lọ́nà mẹ́ta divided by a lọ́nà mélòó? A lọ́nà mẹ́ta. Now, ele cancel ele fún 1, ele cancel ele fún 1, ele cancel ele fún 1. So that means 1 divided by 1 is equal to 1. That is, let's say this is equation 1. Now we know that a raised to power 3 abi divided by a raised to power 3 also is equal to what? A raised to power 3 minus 3. You get now? Do you remember this? Remember the second law. The second law here. Remember the second law. This is the second law. You remember the second law, right? So 3 a raised to power 3 minus 2. 3 minus 2 will give us 0. Abi that will be a raised to power 0. And with this we have what? We have a naught. So that means a naught. This the same value here. If we stop using this, we give you 1. The same value here. If we solve using this equivalent steps, we get a naught. So if we bring equation 1 and 2 together, you have a naught is equal to 1. You get now? That means a naught. This a naught is also equal to well. That means a raised to power 3 divided by 3 is still a raised to power 3 minus 3, which is a naught is equal to 1. So anything raised to power, that's how we have anything raised to power 0 is what? Is 1. So 4 raised to power 0 will give you 1. So 10 raised to power 0 will still give you 1. Do you get that now? So the fourth law is saying that multiple open bracket a raised to power m close bracket n raised to power n is equal to a m n. Do you get that? Just multiply the two. So you have a3 a raised to power 3, which is a lọ́nà mẹ́ta, abi a lọ́nà this a lọ́nà mẹ́ta, abi. Do you get now? Now this a lọ́nà mẹ́ta tó wá jẹ́ kí ni o ká tó wá ṣe lọ́nà ọ̀nà méjì. Do you get now? A lọ́nà mẹ́ta ni. Do you get now? A lọ́nà mẹ́ta ni. Do you get that now? A lọ́nà kan ni. Ó wá jẹ́ lọ́nà méjì because of this power. Don't forget that I told you that anything to this power is saying that okay, we are having this thing 2 times. Even if it's 3 times, we are having this thing 3 times. So since we are having a3 2 times, so we have a3. And what do we have? A3. That means a lọ́nà mẹ́ta 1 2 3. A lọ́nà times a lọ́nà mẹ́ta 1 2 3. So let's multiply it together. A times a times a times a times a times a. Then we have a 1 2 3 4 5 6. So we have 6. So it will now be what? A raised to power 6. So in another way, right, you can say a raised to power 3 open close bracket 2 is equal to what? 3. Where this 3 represents what? M, and we have 3. Where M is equal to 3 and N is equal to what? 2. You get now? So you have A is power what? What is our M? M is 3. What's our N is 2. Then A is power what? 6. You can see the same value we got here. Same value. Yes, that's why you say open bracket A raised to power Mn is equal to what? A raised to power M times N. So those are and another example is 2 raised to power 6 close bracket 3